Hi-oh, here we are again. Part 2 of projectile motion, a conceptual view. This particular part is going to be just questions to get you thinking about how things behave. I have a nice animation to the side, and you can see how a different angle affects various aspects of a projectile, whether it be the range or the height. Something you may not realize about complementary angles, and complementary angles are any two angles that equal 90 degrees. For example, right, 10 and 80 equal 90, 30 and 60 equal 90. It turns out, even though my animation doesn't quite show it exact, but it's it was a free animation, they go the same distance. Any two angles that equal 90 go the same distance, which really makes it interesting when you talk about 45. Notice what's going on. 30 degrees doesn't go quite as far as 45. Go bigger than 30, go bigger than 45, and it doesn't go quite as far as 45. Think about that. What does it do? Bigger the angle, the higher it goes. The shorter the angle, the lower it goes. Every time you increase the angle up to 45, it goes a little farther and farther and farther. Once you pass 45, it goes shorter and shorter and shorter. But if it's a complementary of 90, those two angles go the same range. Which leads to the next question. What will give you the greatest range? Hopefully it's obvious that you see it's 45. Because imagine 0 degrees and 90 degrees. 90 just goes straight up. 0 degrees, it comes out and it's right there. It doesn't go anywhere. It's on the ground. It doesn't go anywhere. So 45 being the farthest. So as we make it larger than 45, I think we already answered that, the range gets smaller. And what if it's smaller than 45? The range is smaller. It's at 45 when you get the largest. So pick a trajectory, any trajectory. What do you notice about the angle that it leaves with when compared to what it comes back with? They're the same, aren't they? Doesn't matter which one you pick. And you can look at the vectors here as well. Look at the vectors. The velocity is also the same. What goes up comes down with the same velocity. We talked about that in class as well when we talked about throwing objects up, talked about free fall. So let's assume that in each case the muzzle velocity is the same. So the muzzle velocity is this diagonal, the velocity at which it comes and leaves the gun. So which one's in the air the longest? Well, hopefully you see, just by the animation itself, the one with the greater angle. Why? How do you know? Because it has to go up higher before it starts coming down. Therefore, it's in the air longer. Other than that, that's it. I'd encourage you to go to this website. It's one I came across, and you can play with different angles, see how it goes, how things are affected. Well worthwhile checking out. Thanks.